In 1971, the United States declared war on cancer. Not as a figure of speech. Richard Nixon signed an actual law, the National Cancer Act, built on the same logic that had just put a man on the moon. Throw enough money, enough scientists, enough national will at a problem, and it surrenders. We had just conquered the moon. Surely a disease was easier. More than 50 years later, the World Health Organization's latest global report puts new cancer cases at over 20 million a year, with close to 10 million deaths, the second leading cause of death on the planet. Left unchecked, that number is projected to approach 35 million cases a year by 2050. Treatments have improved, genuinely, but the word cure still doesn't show up in most conversations about most cancers without a long list of caveats attached. So what happened? Bad science? Incompetence? Not enough funding, even though global cancer treatment is now a hundreds of billions-dollar industry. None of those. The real answer is stranger, and almost nobody explains it clearly. Cancer isn't the kind of problem that money and time alone can solve, because of what cancer actually is. The problem is, it's you. Here's the idea that changes everything once it lands. Cancer isn't a germ that broke in from outside. It's your own cells, running your own DNA, using machinery your own body built, just following a corrupted version of the instructions. That single fact is why curing cancer is fundamentally harder than curing an infection. A bacterium is foreign. Your immune system can learn its shape and attack it cleanly. The line between you and the invader is obvious. Cancer erases that line entirely. The target is you. Killing it without killing the healthy tissue built from identical biochemistry is one of the hardest targeting problems medicine has ever faced. It's also why chemotherapy behaves the way it does. Chemo drugs attack fast-dividing cells, which cancer cells are, but so are hair follicles, gut lining, bone marrow, and immune cells. The drug can't tell your enemy from your ally. It only sees the behavior, not the identity. The math isn't on your side. Your body holds roughly 37 trillion cells, each carrying a full copy of your genome, about 3 billion base pairs. Every division has to copy all of it, and copying is never perfect. Each division introduces a handful of new random mutations. Multiply that by the trillions of divisions your body performs across a lifetime, and the numbers get uncomfortable fast. You survive because of layered defenses, genes that break runaway division, proofreading systems that catch copying errors, programmed cell death for anything too damaged to fix, and immune surveillance that hunts down abnormal cells before they take hold. Cancer only appears once enough of those layers fail at once, in the same cell, letting hundreds of small mutations quietly stack into something that grows without limit. Cancer is evolution, happening inside you. This is the single most important reframe in modern cancer biology. A tumor isn't one enemy, it's an ecosystem. Thousands of slightly different cell lineages competing with each other, each one under pressure to outgrow its neighbors. That's exactly why treatment stops working. Hit a tumor with a drug, and you kill the cells most vulnerable to it. A few, by pure chance, are slightly less vulnerable. They survive. They repopulate the tumor. What grows back is descended entirely from the survivors, meaning you've just run a selection process for drug resistance, live inside a patient. You can't outdrug an opponent that adapts to the drug in real time. You have to outmaneuver its evolution, which is a categorically harder problem. Cancer isn't one disease. It's over 200. Calling it cancer as if it's a single thing is like calling asthma, tuberculosis, and pneumonia the lung disease because they share an organ. Lung cancer, leukemia, glioblastoma, melanoma. Different cell origins, different mutations, different behavior, different treatment response. Even inside one named cancer, two patients can have biologically distinct diseases at the molecular level. That's why a drug that looks brilliant in early trials might work for 30% of patients with a given cancer and do nothing for the other 70%. And you often can't predict which group someone falls into until the trial's already run. Personalized medicine, matching treatment to a tumor's specific genetic profile, is the field's answer. It's producing real results. It's also slow, expensive, and complicated by tumors that keep mutating mid-treatment, meaning the target can shift while you're still aiming at it. The immune system, your best weapon, already sabotaged. Your immune system kills most incipient cancers before they ever become a tumor you'd notice. The ones that become a real problem are, by definition, the ones that learn to hide. Flashing don't attack signals, hijacking nearby immune cells to suppress their own attack. Immunotherapy exists to reverse that. Checkpoint inhibitors strip away the molecular brakes cancer uses to switch immune cells off, and in melanoma and lung cancer they've turned death sentences into long-term remission for patients who had nothing left. But they work in roughly 20 to 40% of eligible patients. The rest have found other ways around them. And releasing the brakes that normally stop the immune system from attacking healthy tissue means some patients develop serious autoimmune reactions in return. There's no clean version of this trade-off. Why it's so hard to kill and still comes back. The original tumor rarely kills anyone. It can be cut out or irradiated. What kills is metastasis, cells breaking off, surviving the bloodstream, landing in distant organs, restarting the whole process somewhere new. By diagnosis, that's often already happened in more than one place, turning one cancer into several. Worse, some cells go dormant, metabolically quiet, invisible to scans and to drugs that only target dividing cells, and sit in distant tissue for years before waking up. That's why oncologists say 5-year survival instead of cured. Cancer-free today isn't a guarantee about a decade from now. The earliest detection wins every time. If there's one lever more powerful than any drug, it's timing. Stage 1 breast cancer has a 5-year survival rate above 90%. Stage 4, the same underlying biology, drops below 30%. The disease didn't change. The amount of time it had to spread did. That's what makes liquid biopsy, detecting the DNA tumors shed into blood, one of the most promising tools in development. A routine blood draw that could catch cancer before symptoms exist, across multiple cancer types at once. Large trials are underway now, proving it actually saves lives, not just detects disease earlier, will take years of follow-up. But finding cancer sooner doesn't need a biological breakthrough to matter. It just needs the treatments we already have to get a head start. The money problem nobody talks about. Bringing a single new cancer drug to market costs an estimated $2 to $3 billion, and that number quietly shapes the whole field. A treatment sells repeatedly to an ongoing market of patients. Prevention barely sells at all. The person who never gets cancer never knows they were supposed to. So money flows toward drugs that extend life by measurable months, not towards strategies that might prevent recurrence decades later. The economics decide what gets built almost as much as the biology does. What's actually working? The picture isn't uniformly bleak. Childhood leukemia, once almost universally fatal, is now curable in roughly 90% of cases. Hodgkin lymphoma went from a death sentence to a highly treatable disease. CAR T therapy, engineering a patient's own immune cells to hunt their specific cancer, has driven full remissions in blood cancers that had run out of options. Notice the pattern. The cancers we've beaten tend to be genetically simpler, more exposed to the immune system, with a clear mutation to target. The ones still winning, glioblastoma, pancreatic cancer, most metastatic solid tumors, are the opposite, genetically tangled, immunologically hidden, physically hard to reach. Both the progress and the difficulty are real at the same time. Where this goes next, AI is starting to do something no human researcher can. Hold the mutational profiles of tens of thousands of tumors in view at once and find patterns across them. mRNA technology, the same platform behind COVID vaccines, is being tested to build cancer vaccines tailored to a single patient's exact tumor mutations. Early melanoma and pancreatic cancer trials are showing promise. None of this is a single cure arriving on a single day. It's the gap between the lab and the clinic slowly narrowing, one specific cancer at a time. Well, let's sum it up. Cancer won't fall to one cure, because the biology makes that impossible. It's not one disease, it's over 200. Each one your own machinery turned against itself. What's actually happening, slowly by the standards of headlines, and quickly by the standards of medical history, is that each of those 200 is being understood and beaten on its own terms. Childhood leukemia first, then Hodgkin lymphoma. The list keeps growing. Nixon didn't declare one war in 1971. He declared 200, fought against an enemy that keeps changing its own tactics mid-fight. Some of those wars are already won. Others are being won right now. Some will take longer than anyone wants. But the side fighting them isn't losing, it's learning, and in medicine, eventually, those turn out to be the same thing.